In this video, we're going to talk about NetworkX. We're going to go over some of the concepts involving its use and some of the instructions to actually use it. So what is NetworkX? So it's a tool for analyzing networks. So if there's any sort of relationships in the data that are networked together, we can use Python, and NetworkX is something that we can use in Python to create and visualize those networks. So actually see them and actually create the data structure that actually allows us to visualize those. So this tool is really good for analyzing connections between things. So if two things are connected, this is a really good visual for showing that. So things like social networks, where you have a lot of people following lots of different people, and you have influencers, and there's pockets and niches and hashtags. All those things are related, but in really complex ways that are best described in a visual. That's something that NetworkX can help with. So if you ever want to map routes, like logical routes between different ideas or different pockets of information, one of the ideas behind this is that you could understand web link structures, so like websites and their various structures, back to like the home page and the about page and like the cart, and how things like that are laid out, just as one example. So an example of a NetworkX visualization here, this is World Chess Championship games from 1886 to 1985. So every major node is a player, and the edge width is the number of games played, and the node size is the number of games won. So the bigger nodes, and those are actually those purple balls with the names on them, those are the nodes, and the edges right here are these slightly like less purple, more pink bars kind of connecting all of them. Right here, so like all this together, the title, the edges and nodes, everything in between, this is all a visualization that you can make with NetworkX. And just to highlight that visually, here's some red boxes around all the examples of nodes right here. There's a bunch of other ones here, but these are just pinpointing some of the nodes. And then right here, these would be the edges, and we'll talk about these again later. So the various parts of a NetworkX visualization, we kind of just touched on edges and nodes, but we'll talk a little bit about more of how those work. So edges and nodes, so a graph is what we're calling the visualization that NetworkX outputs. It's composed of nodes, and those represent entities. So those could be like people or cities. And once again, here's an example of some nodes with those chess players. And then edges, nodes are connected by edges, and those represent relationships. So those could be friendships or literal roads, right? We could have roads connecting cities. And then all of this is used to visualize data, but this is a specific niche of visualizing data, and you kind of have to have a certain type of data set or a certain use case to really make use of this visualization. So when it comes to actually visualizing the graph in NetworkX, we're going to use matplotlib, which is another Python library. And so packages and libraries, it's a very similar concept, but matplotlib, what it does is in NetworkX is it allows us to visualize things. So in NetworkX, we create graph structures. So we create those graphs, we construct them, we build out what the data is going to look like and all the rules for what data is going to be hosted where in the graph. And then with matplotlib, we actually use the visualization tools that it provides to just represent the data and visualize the graph. And then that ultimately gives us the presentation for us to analyze and just kind of explore that data. So that's sort of how all these pieces are working together. One of the things that's important to understand as we begin to work with NetworkX is we need to understand where we can work with it and what tools we would use. So NetworkX is part of the Python ecosystem that is kind of all the tools that we could use. And one of them is called Google Colab. And Google Colab is integrated with Google's other stuff. It's in the web. It's very easy to use. And it's really a notebook style way of using Python. So it's integrated. Python powers Jupyter and Google Colab, right? And so we can use network inside of Google Colab, and it's Jupyter and Google Colab are very similar, and they're really kind of overlapping concepts to a Python notebook. So Python is just one of those core programming languages, so it's kind of used in a bunch of different ways. It's sort of similar to like something like JavaScript, which you actually see and interact with every day, and you probably see and interact with Python every day, even though you don't know it. And Jupyter Notebook is just, it's part of that ecosystem as well. And NetworkX just kind of overlaps the Python ecosystem, Python, and all those things are kind of just related. And you can use NetworkX inside of Python and inside of a notebook and inside of Google Colab, which is ultimately where we'll probably demonstrate a lot of this. So to use NetworkX, we're actually going to have to install it first in most environments. And like we just talked about with notebooks and places where you could use Python and work with them, you are going to go ahead and install it with something called pip. And pip is a Python package manager. And it just allows us to work with different packages that are available in Python and install things. And once that's installed with pip, then we would go to use Git, which is a place that code is managed in different versions. And then we would take what's called a repository of the code for NetworkX, and we would clone it. We would take it and we would bring it into our environment. And we would use a command line. And when I say command line, that's just really something that allows us to execute commands like installing NetworkX. And when I say commands, I just mean writing lines of Python that do things. And just to show you some of the steps that we would take, some of the code we would actually write, some of the things we would do, we would go ahead and check our pip version first. So that would show us that we're at pip 23.1.2. And then from here we could pip install upgrade pip, right? Make sure it's all the way up to date and upgraded. And then we would go through and install NetworkX. And right here, this is, once you write this code, with or without these comments with the hashtags before them, you just go ahead and click play, or you can do shift enter, and that will run these. So right here, I'm going to click shift enter, and then I'm going to say pip install upgrade NetworkX. Just make sure it's all the way upgraded, all the way up to the latest version. You can click X there if you want to kind of remove the output. And then in case you need to do this for some environments, this might be needed. Just if you don't have system-wide permissions, which is something that you'll probably find out because things won't work. And then if you just want to install NetworkX without any of its dependencies, you can just install this. Chances are you may already have everything if you've done the previous code right here. And so it may say something like this, requirement already satisfied. So here we go. Now we're going to git clone this repository. And feel free to go look at that. And then this is how we can actually go into the working directory, basically the folder of the cloned repository. And then right there, if we need to do any extra packages, we could do that. And this is kind of just from the documentation. This is just a Python testing package. So if we ever need to use that later on when we're working with it. And then here's where we get down to the good stuff. So this is exactly how you import NetworkX. So you would just say import NetworkX as NX, and that's just a short thing to type as opposed to typing out NetworkX every time. Sometimes people just do NX, right? And like we talked about with matplotlib, this is us importing matplotlib.pyplot as plot. And this is what we can do to create an empty undirected graph. And so when we talked about the nodes, this is a code where you actually say, because G equals graph, right? If we want to add nodes to the graph, we can actually just say add node Alice, add node Bob, and those would be our separate nodes that we could actually output. We can also add nodes from a list. So if we have like a list of names, like these are all various first names of different politicians, then you could add the nodes from that list. And if you wanted to add attributes to the nodes, you could say add node of this name and then say an attribute like a party equals Republican or equals Democrat. And just as an example, if you ever wanted to print out what nodes you have in the graph, you can just say print out the graph and then nodes in this syntax right here. This will tell you all this information. Here's the number of nodes and edges in the graph. Also, to talk about edges, you can add edges, and remember those are those connection points between two things. And you could say between the nodes of these names, you can actually add an edge. So you can say between these two people, and between these two people, and between these two people, and between these two people. This is your list of edges, and then you can add edges to the node G. Okay, so now if we want to talk about actually outputting the graph, you'll remember that we brought in NetworkX, but then we also brought in pyplot, so PLT and NX. So those are both in play here. So right here we have this layout. And right here we have all the setup for the various labels, node size, colors, font sizes, kind of the aesthetics. Now right here we can get to the labels. And right here we have an attribute. Remember, we added that back here. We added attributes of the party affiliation. So those are coming into play here. We're going to have those be the node attributes of party. And then those are going to be made visible here. And then we would display the graph, plot title, plot show. And that's actually going to push out this visual right here. And you can actually play with this code a little bit. If you want to go in, you can always take this and say, I want this to be font size 16 or font color red. And you can see the different outputs that it creates depending on things that you change. And if you ever want to comment something out and see what that looks like I could remove the labels of the parties. You would just go ahead and comment things out, and you would see how things fall. So see, this is just the names right here. And maybe what you could do is work on a red, blue breakdown for something like this. But as we were talking before, that we use NetworkX to define the data. If we ever wanted to remove two nodes, so we have two names, Frank and Eve. And if we wanted to remove those, we would say remove node Frank, remove node Eve. And then we would update the graph after removing those two nodes. So we run through this code right here. Basically line it up again and run that. And as you can see, those two names are not available on the graph.